So the talk today is customer record deduplication using Spark and Reifier, and I'm so glad last day of the session, last session of the day, and you guys are here. So thank you so much for making it. As I was just introduced by Fabian, I am Sonal, and I'm the founder of Nube Technologies. We've built a solution for data matching using Spark and machine learning. I have with me Dave Chan. Dave is Regional Director, Business Intelligence, UBM Asia. UBM is a leading event organizer in Asia, and Dave has been one of our earliest customers, and a lot of what we have as a solution today and what we're presenting today is due to his team's feedback as well as what we were trying to build as our vision. So coming to the problem that we are trying to solve, looks like a very trivial problem, but it's a problem that plagues a lot of industries. Dirty data, duplicate data, the same entity being represented in so many ways with various kinds of typographical errors, no standardization of fields. It's really very difficult to figure out whether all these records refer to the same entity. And what I have here is just a sample of how bad the data can be. So if you look at this, not a single field here is matching with the other one. Although humanly, it's very easy for us to figure out that they're probably the same person. And the complexity here increases when we talk about addresses, when we talk about phone numbers, when we talk about organizations, when we talk about products. So there is a wide variety of ways in which data can go wrong in terms of omissions, in terms of spellings being wrong, in terms of ordering being wrong, in terms of entire fields being wrong or completely missing, lack of standardizations in various source systems, and that is the problem we are trying to attack. So this code kind of sums up the problem that we are solving. If you have to be irreplaceable, you have to be unique, you have to have some differentiation. And now, where is this problem of matching actually applicable? So customer record deduplication is definitely one application of what we are doing, but what we also see is that the solution that we have, which is data matching, or also referred to as entity resolution, record linkage, record matching, deduplication, has applications in basically all kinds of enterprise systems. So if you are trying to find a single view of your customer, or basically as a business, we want to have an understanding of what are the various stakeholders who are associated with us, how do they interact with each other. Unless we have a complete view of what are the relationships, what are the patterns, so master data management, CRMs, any kind of data analytics that we want to do, we are not able to do that if your underlying base data is not clean. In terms of compliance, there are a whole lot of use cases for data matching. When you want to match yourself against lists of entities you don't want to interact with, vendors you have blacklisted. In terms of competitive pricing, as an enterprise, I want to match as an e-commerce vendor, what are my competitors selling for what? So that is another use case for matching. Now, this is a very common problem, but it is challenging in its own ways. If we look at just 100,000 records, and because there are no unique identifiers, comparing 100,000 records with 100,000 records makes it 5 billion comparisons. So automatically, just the scale of the problem, even with a small data set, increases unless we apply some smart algorithms on top of that. Now, it is also very difficult given that the problem is applicable in so many different domains, in so many different fields. How do we discover the rules where we say that let's look at the first 3 characters of this field, and then if they are matching, let's look at the last character maybe, or maybe replace some of the strings with something else. Okay, maybe I can do it for one field, but will those rules apply to the next field and the next? Will the same thing hold for products, for addresses, for house numbers, for names, for last names, for salutations. Can we handle all that with our rapidly growing and changing data? So that is the fundamental problem: scale, variety, and just the sheer possibilities that data can unfold. So on top of it, as organizations are growing, our data sizes are also growing. So I mentioned this case of 5 billion comparisons, and you can imagine if we go into millions of records, the kind of computation power and the kind of matching we would need. So that is one. Then again, as I mentioned, that each record will have multiple fields, so capturing rules across all the records is going to be tough. And languages, which Dave is going to cover later as part of this use case, will have their own challenges. So what matches, even if we capture some rules for English, those rules cannot be translated to Chinese, to English, to Thai, and to Hindi, and to other languages. So if you have multilingual data, or if you want to have a common system which can attack this problem for all your data, it becomes extremely challenging. So how, now given that this problem is a complex beast to attack, what is the best way we can look at this? So one way is that we try to figure out rules, which has been the conventional way. We look at some algorithms, phonetic distances, edit distances. We say on a field basis what is a good score, and then combine the scores across multiple fields, and then play with thresholds to figure out whether a complete record across all the fields is matching or not matching. The second take that we can do is, because we already have a lot of new wave technologies like Apache Spark, which can help distribute our load. So if we can find a smart way to partition the data, we can actually attack the problem of the quadratic nature of matching, and if we can apply machine learning. So if we say, let's not have any rules at all, let's just move away from it. Let's just start learning from the data itself. Let me see what the data is telling me. Are there some rules inherently in what kind of matches we have? Can we generalize them and build something? Can we learn from the data itself? So that is the approach we have tried to take. We are using Spark heavily. So Spark for distribution, machine learning for learning from the data and figuring out what is matching and what is not matching. So what is a typical matching workflow looks like? A typical matching workflow starts with configuring your data. So basically, we look at the fields. We identify the fields, your data source and your fields, which we want to match across, either within a single system or across multiple source systems. And then we want to learn from the data. So we want some samples where we say, this is my sample, this is matching. This is my sample. Records which probably have differences like these, we don't want them to match. So let the system figure out what it wants to match based on that. So if you have training data, that's great, we can start there. If you don't have training data, why not create training data? Because we already have the base data. So that's how we run across this. So if we have training data, just throw it at the match process. If you don't have training data, create some training data, feed it to the match process, and you have your linked data set. So how do we learn? A way to learn is obviously, like as I mentioned, that you have your base data, we throw it at the system. It tries to find some random sample pairs which apparently to it are looking matching. Now in a typical data set, positive data set or matching data set is going to be a small number, and negative non-matches are going to be far more. So in the first few rounds, what you're going to see being emitted out are typically non-matches, but it'll still try to figure out, let's try to figure out at least some kind of matching. So if you look at this example, there are some kind of similarity. So it's not a complete random pair. There is some similarity between the first two records. Again, there is a similarity between the next two records. We can choose to label them, yes, they are matching, or we can choose, according to our business rules, that no, they are not matching. And this is something that even a temporary hire could do that, or a very, a temporary staff could do that, or a person who just understands the business but doesn't need to know much about the technology can do that. And then let's feed this back to the machine learning algorithms and let them figure out. So they started at a base, but the base was off. So let's feed this back to the system. And then after a couple of rounds, so here this is, we've labeled about 35 pairs. So it starts learning whether it's clustering them smartly enough or not. So it's now looking at more and more fields. So if you look at this between the last example and this example, the records, the more number of fields are actually matching with each other in terms of name, in terms of address, in terms of postal code as well as state. And similarly, we go further down the line, and after we've labeled a few more records, the rules are further refined because we've had more samples to look at, and then we can actually learn far better. So at this point of time, we can say, hey, we have enough training, let's take a run. What is my output? How does my output look like? If I'm satisfied, let's deploy the model. If I'm not satisfied, let me take a few more rounds again. So it becomes very easy to do this kind of modeling, which is directly in the hands of the business user without any kind of configuration or any kind of coding needed, or any other custom implementation which is needed to do that. So all this kind of feeds back into our proprietary clustering as well as classification algorithms. Our architecture is very heavily Spark dependent. We chose to use Spark 2 years ago, and I think that was a very wise move that we did, given the traction the project has got, the kind of new APIs that have come up, and a lot of support of machine learning that has now been added into the base platform itself. We are using part of graphics, the Spark core obviously, and the MLlib library. On top of the MLlib library, we have our own proprietary clustering as well as classification algorithms, which take data from, which basically learn from, so it's a supervised learning algorithm, which is taking the feed from the positive and the negative pairs that we have labeled, and then creating a model which can be deployed. So the benefit of Spark is multifold. I mean, there's a whole list of advantages that have come with using Spark. First is the directed acyclic graph that we get. If we were doing this as a MapReduce program, we would have really gone crazy just orchestrating the multiple jobs we would have created in terms of filtering, in terms of transformations, in terms of figuring out distances between pairs of records, in terms of random sampling, in terms of scoring those pairs. So Spark in that sense, because we have so much computation happening, has really helped us. A second way in which Spark helps us is that it keeps our data set in memory as far as possible. We can obviously tune it, and we recently did a POC where we ran against 40 million records on a 3-node cluster in 2.5 hours without much tuning, because it's and it wasn't very heavy memory usage either. So the benefit that we get there is that the data is held in memory, and we can keep looking at it again and again, computing various scores, and come back and say whether things are matching or not matching. And if two records are matching, is the entire graph matching, or are 5 records matching with each other? So Spark has a wonderful API to use. I would recommend if people who are not using Spark to go ahead, try it. So in all senses, we couldn't have done it without Spark. So as I elaborated, what are the advantages of using and building a system like this? The advantages are that the algorithms, so I think as users, we've got used to a lot of personalization and a lot of smart algorithms, at our beck and call. We can talk to the phone, we have personalized algorithms which will recommend things. But at an enterprise level, we still have our archaic systems where we have developers thrown into a problem, they are tweaking algorithms, they are looking at thresholds. our approach has been different in that sense. So this is directly, if we talk about self-service, this is self-service. If we talk about scalability, this is scalability thanks to Spark and thanks to the partitioning that we are doing. So it is a point and shoot, zero configuration kind of a system. This approach also helps us in creating a system which can be applied to a wide variety of systems. So not just, enterprise customer records, product data, or address data, or organizational vendor data. So just because if one single decision of learning from the data actually helps in simplifying a lot of things and opening a lot of doors in that sense. What we also discovered, though this was not by design, but our model has proven to work very well. The same model has proven to work very well on English as well as Chinese and Japanese data. And Dave would be elaborating on exactly his use case and how it has worked in his case later. So, because you learn from the data, so it's all there. It's for us to discover. So another thing I think I just forgot about, and before I hand over to Dave, is that so this is a batch, this can be a batch operation, but in a lot of cases, we may have a lot of records internally and we may have a few records coming and we want to match them, like in the case of typical banking setup where you have one record coming in and you want to say, hey, is this blacklisted? Do I want to give a loan to this person or not? So because this architecture, this model can be deployed also in real time. So we create the process, the model as a batch process, and then we can deploy it real time. So those are the advantages of following this kind of an architecture. I would now request Dave to actually cover his specific business use case, what was his approach, and how we are solving it through Reifier and Spark.
Okay, thank you, Sonal. Thanks for everyone for coming to this sessions. I'm so happy to be, of course, helping Sonal to be the voice of the customer, because I've been with the data industry for 15 years. I was working for a major bank. Before that was healthcare, and now in media. And UBM Asia is the largest event organizer in Asia, the second largest in the world. I have seen so many different flavors of technology packages that attempt to solve problems like this, like deduplication. And when I come to UBM 4.5 years ago, this is particularly severe, because the reason is, in Asia, as you can imagine, our events are across multiple, like all kinds of verticals. So you have people, jewelry, industry people that do water, concrete, baby products, and all kinds of products. And many of them, they're becoming more tech savvy, but traditionally the industry is not very tech savvy. So what will happen is there will be 70%. So on a normal event, we'll have 70% of people who come to the event with no preparation. I mean, they just, okay, this is an event that I may want to check out and find my supplier, but they didn't pre-register. So meaning that they haven't gone through the online platform where they can type the information. So they come on site, they grab this paper form and they write, find somewhere and write on someone's back or whatever, just write their name on it. So, and then you can imagine the data we collect through those paper and transcribing it, of course, using low-cost temporary stuff, right? Transcribing it and then input into the system, multiple layer of errors. So when I took over the data team and look at the data we have in Asia, it's crap, right? That's why we never done loyalty analysis. It's never successful. We've never done basically the downstream services, right? We never even attempt to do it, because it's the data has so many duplicates, and people day in day out just suffer. The marketing team, they don't even want to touch the data, right? You handle it. So then we realized, okay, we really have to get serious about it. And I asked around, right, people from our divisions in the West and see, how do you deal with the problem? And actually, some of the techniques we also employ before we use Reifier, the solution, is I think Sonal also mentioned briefly, right? You match the first few characters, or the exact match of the phone number. But the issue is, this is a real case. A couple of years ago, because we serve so many SMEs, right? The family business. Son and father had the exact same name, exact same, of course, company address, everything the same. And then, of course, the really like simplified matching approach merge them together, and that become problems later on. Like when we contact them, and of course, what we really care about is the number of people attending our event, because that's public figures, and because of those duplication, that number actually got reduced, and of the type of non-precise matching, it becomes quite problematic as we report our figures. So our problem, so fundamental problem is this, right? Duplications from multiple sources. We have also data from directories that when we go to competitor events, so we collect those names. And of course, some are overlap with our existing data. We also have portfolio events, so that there will be a jewelry show in India, jewelry show in Hong Kong. So both will be collecting data about same people. So there's so many sources of attendees data that potentially overlap. So that's broadly the problem. And then the problem of a lot of the solutions that try to attempt the duplications, English-based. I think initially I went out to a US vendor, but they couldn't do Chinese, couldn't do Japanese, couldn't do Korean. But our data, China alone is taking 40% of our databases. So we have to address that problem. And then I come across Sonal. I actually found her speaking in the Spot Summit, and realized, well, that could be a good fit. And so I give her some data set, and she was kind enough to say, let me run it, let me show it to you, because I know a bit about machine learning, so I know if she's lying or she's really telling the truth. So I sent her the data, she ran it, and then I actually look at the console and see how it works, right? And look at the results, get the result, pass it to my teams, and they validate it. And then we got like 80% plus accuracy. Pretty good, right? And then we say, okay, let's try more. So I think we had a couple trials before we say, this will be the right vendor. Right. So this of course is a bit of learning, but now our workflow of addressing this particular problem is we have a data set. So that's of course coming from our database, very messy kind of data, and then we're running on AWS, right? So running waivers, and so we run the workflow. You see, run the program you see earlier, the interactive. Well, I think before you have the interaction, you actually is a Linux-based console. So my team actually got scared because I don't know Linux and how to work. So now it's guiding us through. But now she has a UI, so it's good news. So I can actually give people in each office, they can run it on their own. And so we'll identify duplicates. Now, you will still see human in here, and which is I think the key point, because machine learning is not supposed to replace what humans are good at, right? You want machine to do what machine's good at. And when the machine is not 100% accurate, will never be. Maybe Google say otherwise, but I think in general it's never be 100%. So, but when it's not 100%, if they are false positive, and then when the data actually get merged, it can be quite, it can be catastrophic, right? What if that customer is your loyal, like your key customer, right? That could be really upsetting. So we have actually temp staff who, after the results of the program, they will eyeball it. So the positive matches the cluster. So they will go through each one and they will say yes or no. Is that a good match or not? That's actually what the supervised learning come from. So we have an initial set of learning that we do together, tuning, and then for each run there will be maybe 20% of them that are bad matches. And then the 10 will identify those for us, and then we will add it to the positive and the negatives, and for the next round. So we do it for separate language, because the neurons is of the different languages. And then we do the merging within our platform. So we upload that list and then merge it to the platform. Right, so not going to cover that. So this is just what you mentioned earlier. Not going to cover that either. So that's just how we get the data. Yeah, so that's the UI. Well, you see it's pretty neat. So we upload the files onto the platforms, right? And next is when we then define how we match each field. Now, of course, if we have I think for some the deduplication that we have done for the same kind of data set, that we don't have to define it, it gets saved on the platform. Yeah, so we define like what are the pre-processor of the field, meaning that we need to clear out some stop works like ABC company, so we take out all the company, and take out some really common names within some languages. And so the stop words will clear them, and yeah, just the type of data is in that field. Right, so an example of the raw data we have, right? There will be some companies names, Asia. So in Chinese this is Asia and a company name and then limited, right? So we have to get rid of that. So basic things, the company names don't match, and therefore we will not group them together. Right? So as the results, we'll indicate that we will not group them, but otherwise we will group them based, of course, on the learning algorithms that one at the back, like learning the weight of each field, right? Okay, and here's the positive and the negative. Like I said, we tune them every few weeks, and just to get to a higher percentage of matches. Right, so that's the lot of the data, the runs. Right, and then we download the duplicates. And here's the manual verification. So you see the group, column B was the group, so that's the cluster. So one nice thing about the solution is that it can group all of the likely duplicates. So you don't have to, you don't overload the system of finding, the same person actually appear in 30 records and have to merge them by pairs, because it would be quite a lot of low on the databases. Right, so that's what we get, and the attempt will go through this. Right, these are the key fields in our data that we use to identify whether someone is a unique or not. And here's just our internal system interface where we upload the files. So that's the easy bit. So key benefits, I think. Well, first of all, cost-wise, because we are a cost center of running these solutions. Cost-wise, actually, we run it for a year. It actually saves us money, rather than, of course, the accuracy and the payoff for the downstream, like loyalty analysis, retention. Those are the campaigns that we can actually now start to do. And so before we use Reifier, we have 10 staff who eyeball the whole 6 million records. So we have a team of 10 staff that sit there in our office all day, 5 days a week, all year, just to go through and randomly check and find, maybe they will search like starting A, okay, A, N something, and get the list of people and find if they are duplicates. It costs a lot more than the solution plus the 10 staff who just have to say yes, no, yes, no, yes, no, right, with those possible matches. So obviously it optimizes our marketing. So like I said, loyalty, because then I can see, so typical cases we have 2 persons in the database. One have attended our event 5 years, another attended the previous 5 years. So if without the deduplication, we'll assume there's 2 persons. We may classify them in a certain loyalty bin, but then when we combine them, we know that, wow, this person we're gonna do something for them. So marketing-wise, it's crucial, I think, to have a good deduplication workflow and engine. So yeah, like I said, attention, retention, loyalty, and it's really easy to configure. I think you do it once, and then you just keep uploading the same, a similar data set, so just let it run. And it's also quite handy. It's like plug and play, right? No matter what system you have, you can always export data out there, and you can always run the algorithm, get it back. Of course, we will start to look into how we can integrate the solution. Like Sonal mentioned, that you can actually do it real time. Spark can do it real time, so we can look in how we can do it real time as people are entering data, right? And multilingual, that's a key. I think that's a key advantage over some of the existing solutions out there. That you can throw any kind of languages data and produce its own like positive, negative, and you can still run it and will get a good percentage of accuracy. And it's scalable. right? Because you just dump it on the platform, dump it on AWS and let it run. So you pay more, you run faster, so it's simple math. Right. And yeah, I hand it over to you and happy to take any questions if you have. So thank you.
Yes, I have two questions.
Sure.
One is, so do you have to do the manual verification process for every positive pair?
Every possible, yeah. Well, you need you need to see because you never know, right? So we'll still have to go through each pairs. But is there a particular concern that you bring this?
My second question is, so
Yeah.
before this solution, you have 10 people looking at your records that duplicate or unique records. So now you have a few. How many people are looking at the manual verification?
So we usually now we don't do it. We don't have someone who sit in the office like the whole week, right? So we will lump it together when we have. So we do it in batches at the moment. So we'll run this for all the data one time, like in a week, and then we'll have people come in and do it for 2-3 days. So they just 8 hours a day sit there and just go through the whole list. So yeah, so but depending on how fast your data is coming through, right? For our industries, it's throughout the event cycle. So we have we have on average 5 to 10 events in a month, and then and when we do this, maybe just 2-3 days in a month where we have someone who would just do the manual verification.
Yeah. So to answer, sorry, let me just add a bit to what you were saying, to what they were saying. So this manual verification is also, I think, very dependent on this particular use case. But what we also have is internally scores at which we are saying that the cluster of records are looking together. Maybe in some cases, if we expose that score, that itself is a good enough starting point for someone, probably as a score.
It's a good point because we are ultra conscious. I mean, not me, but the team who use the data ultra conscious, and they're willing to pay that extra little money for manual verification. But like Sonal said, the output actually had the score. So you can say like, I don't like blind. I just don't look at anything above 90% likeliness. Just merge them, and then I'll look at everything that's between 60 to 85. So it could be a more like a balanced approach to it.
I have a question it's more technical.
Right.
Let's take the use case of name matching, and let's take the example of inner names. When it is like double A at the last, then gender will be changed. Let's take so here let's take the example of Gita. So first GEETA and GITA, both of them are the correct one and the matching one, right? So and another case Rama, Ram, it's a male, and RAMA, Rama is the female one, right?
Okay.
So in this scenario, how it's going to compare? Did you get this kind of challenge?
Okay. So I get asked these kind of questions multiple times in various ways. I think my answer has always been, and I think that's the right way to go, is a machine can only do less than what a human can do. So if I'm just looking at the name record, if I have Rama and Rama, as a human, if I'm not an Indian, even if I'm an Indian, it's very difficult for me to say whether they're the same person or not. So how can a machine actually figure that out? So unless you you add more information around it, probably a machine can, if looking at M and F, it can figure that out. But what a human can do, a machine definitely cannot do.
Yeah, you need Indian trainers for that.
Yeah. Good point. Yeah.
Good find.
Another question.
What does that with the algorithm fit into the system? Do you do on the first iteration getting the data set that is a trickiest first, so that on the subsequent iteration actually the learning is much better, easier?
Okay, so what we do at every iteration is we randomly sample from the bigger data set and we compute probable pairs. The ones we are most uncertain about are the ones we throw back at the algorithm. And then again, once we have labeled, we go back and randomly sample again. So we don't randomly sample once and then keep iterating over it. We sample once, we learn, we feed it back, we sample again, we learn and we feed it back again. Does that answer your question?
Yeah.
Thank you.
What are the algorithms here?
Okay, so the algorithms at a high level are clustering and classification algorithms. Both of those algorithms are actually proprietary. I'm sorry, I cannot go into much details over them. These are built over MLlib, but they have a lot of extensions over MLlib. We do a grid search on the best model that we need to find. So there is some element of grid search and proper so there is traditional clustering and classification, but we are not using off-the-shelf k-means or SVM or anything like that. We have our own algorithm which does that, and the reason for that is that traditional k-means and all will work if you already know the cluster sizes in advance, which is not how it works in deduplication.
And where you are using graphics, like you also said you are using graphics.
Yes. So we are using graphics once we have pairs. So basically at the core of it we do pairwise similarity. Once we have the pairs, we create a graph and then cluster them together to find which group of records are similar to each other. Yes, please.
Are there sort of plans for the product to be more of a data quality, like a generic tool rather than sort of similarity matching? Could you do sort of anomaly detection or fraud analysis type things?
I would love to. So far we haven't tried that. So I think what we have as the base algorithms can actually be applied in a lot of use cases. So far our hands are full in just matching, but yeah, I would love to explore that.
Do you have any free version of it for testing?
That would be nice, Sonal. Think about it.
Let me think about it.
Any other questions?
This is deduplication about the customer data.
Right.
Do you have any concept about using this for deduplication for transaction data? Like if there is some transaction is going in, how to detect a late CDR or late records or something like that, duplicate records and everything with a very large set of data. Is it considered also deduplication?
Okay.
Is there any experience on that or?
So honestly, so far we haven't tried that, but I can take a look and try to figure out if we can do that.
But it's quite generic. Right? I think you see the page where you define the field. You can define anything there. It's just that in particular when you mention transaction, right? What are the key fields that you need to use to identify, and are there specific business rules behind it? For us, it's I think the name, company, people's name, and the phone number. There are rules behind it. But I mean, to your transaction, maybe there's business rule that can be built in.
Those could.
So I would say that you can actually do
probably that. Those can be discovered. Yes.
Yeah.
Yeah, just do what Dave did and give us some data and she'll come back with the results.
Exactly.
Yeah.
Any last question?
Throw the data at the system and it will figure out.
How much time do you guys spend on engineering? Because if it's works with specific languages and so on, you probably want to include certain language models for actually like using demonstrations. So how much time do you spend on
In terms of development time or in terms of runtime?
So say for each data set, so once you get an English data set, the other time you get a Chinese data set, how much time do you spend in building a model?
Okay, so the same model for us has worked between English, Chinese and Japanese. We recently tried Japanese and Dave has been happy with the results. The reason is that we are looking at differences between two items. Internally, we don't have the intelligence of what is English and what is Hindi, or what is French or Chinese or Japanese. So in our case, it doesn't really matter. So we don't have any language models built in. We use a combination of similarity metrics and we have a lot of custom implementation behind it as well. So the only change that we had to do while supporting Chinese was that we wanted to increase the accuracy, and that's when Dave suggested that, because we didn't understand what Chinese what are the nuances of the language. And that's when we met, and Dave suggested that maybe we can add some stop words and see what are the results. And that's where the screen that he showed was, we added a few letters, Dave, please correct me if I'm wrong, which were common across a lot of the data set, but they really changed the result. So that is the only variation we have done. For Japanese, we have not actually made any changes.
Yeah,
so
Japanese actually, it works quite well just with the English model. Actually, on the Chinese, because Chinese characters, you have 2 words and can be very different, but by English, like 2 characters is nothing in the whole names. Therefore, we have to clear out all the similar, like really common words. But the model, it's been quite robust. At the moment, we don't have to vastly use different set of training for at least English, Japanese, and Chinese. We still have a separate model.
Chinese, we don't have a separate.
We don't have it. Okay, yeah. So just the stop works. It's been good enough so far.
It is not only edit distance, there are a lot of other things as well. We look at phonetic distances, we look at sound X and stuff like that, and we have some internal features as well.
In summary, it's proprietary.
Yeah, in other words.
Yeah, I'm sorry, but so the solution is proprietary, but I think the key takeaway from this is that it's if we apply machine learning to a variety of enterprise problems, we can really create very smart applications which are easy to use, which provide a lot of power, and which can really make our lives simpler.
Yeah, thank you very much.
Thank you.